Good day, student. Welcome to my channel. As promised in the last video, this time around we are going to be looking at resistivity and conductivity of a material, which is the last aspect of the topic that we discussed in the last video. Let's quickly consider the lesson objectives for this particular one. By the end of this lesson, we should be able to define resistivity and conductivity and probably state their units. Also, we should be able to explain the factors that affect the resistance of a conductor, and we'll be able to solve problems related to resistivity and conductivity of a material. Okay, let's quickly look at what Ohm's law is saying about the factors that will lead us to this resistivity and conductivity. Now, if you can remember, according to Ohm's law, the voltage across a conductor only affects the current that is flowing through the conductor, because it is assumed that all other factors are kept constant. That is, physical factors like temperature and some other things. So it means increase in voltage or changes in voltage does not affect the resistance of an ohmic conductor. That is, every conductor that obeys Ohm's law, variation in their voltage does not have any effect on their resistance. It only affects the current according to Ohm's law. But the resistance of ohmic conductor can be affected by some other factors, which we are going to quickly discuss now. So what are those factors? Number one, length of a conductor. The length of any conductor also has a little effect on the resistance of the conductor. How does the length affect the resistance of a conductor? As you can see from the diagram under the factor there, you can see a longer conductor and a shorter conductor. And from this pictorial representation, we can deduce that for charges moving through a very long conductor, it takes more time for the particles to move from one end to the other end, while it takes less time in a shorter conductor. So we can translate it to the obstruction or obstacles that the particles will encounter in these two conductors, so which can be likened to the resistance. So we have more obstacles in a longer conductor than in a shorter conductor. So if we consider this, we may say, or we may conclude that the longer the conductor is, the more the resistance it offers, which mathematically we can say the length of a conductor is directly proportional to its resistance. Okay, let's look at another factor. The second factor we'll be considering is the cross-sectional area of a conductor. What is cross-sectional area? That is the area through which the current will flow into the conductor. Now consider another pictorial representation. We can see a wider conductor compared with a thinner one. In a wider conductor, we have more space for the electron moving through the conductor to occupy, so which translates to more space for current to flow through. Now, in a thinner conductor, we have little space for the electrons to pass through, which will make the electrons to encounter some obstacles in passing through a inner conductor. So we can relate this with the resistance of the both conductor, which means in a wider conductor we have less resistance, while in a thinner conductor we have more resistance. Mathematically, we can as well say the resistance of a conductor is inversely proportional to its area. And other factors that also affect resistance of a conductor are the temperature, which is having a direct relationship with the resistance of a conductor. That is, the more the temperature, the higher the resistance of a conductor. And lastly, we are looking at the nature of the material of the conductor. From our general knowledge, we know that materials such as metals offers less resistivity because of the availability of free electrons in them. They easily allow the passage of electron or charges through them, while non-metal in most cases offer high resistivity. And what is this resistivity? Let's quickly look at what resistivity is and how we relate it with a resistance of a conductor. Now, resistivity, which is represented with a Greek symbol rho, is the property of a material that determines how strongly it opposes, that is, how strongly it resists the flow of electric current, and it is measured in ohm meter, which means this resistivity, which is the factor of the material through which the conductor is made from, this resistivity is also having a direct relationship with the resistance of a material. The higher the resistivity of a material, the higher the resistance it offers. So bringing all these factors together in a simple equation, we can see that resistance of a conductor is directly proportional to its resistivity and length, while it is inversely proportional to the area, and that is what will give us this equation R, which is resistance of a conductor equal to the product of resistivity and the length of a conductor divided by the area, the cross-sectional area of the conductor. And if we make the resistivity the subject of the formula as well, we have rho equal to product of resistance and area divided by the length. And there's another term that is closely related to this resistivity, and the term is conductivity. This one is represented with a Greek symbol, sigma, and is directly opposite of resistivity because it is the measure of a material ability to conduct electric current, and it is the inverse of resistivity, and it is measured in inverse of meter, which means if we are asked to calculate conductivity of a material, we can easily calculate resistivity and find the inverse of resistivity. Or probably we may say conductivity equal to the length divided by the product of resistance and area of cross-sectional area of a conductor. Let's quickly consider some examples that has to do with resistivity and conductivity. Okay, now the first question says we have to find the resistance of a wire of length 0.65 meter, which is having a radius of 0.2 millimeter and resistivity of 3 times 10 to the power minus 6 ohm meter. How do we go about this? And in a bracket, we have the value of pi given as 3.142. Now, first thing to do when we have a question like this is to write out the given parameters. And according to the question, our length is equal to 0.65 meter. The radius of the wire is 0.2 millimeter, which we can quickly convert to meter because it is important that we have all unit in SI unit. And converting millimeter to meter, we divide the value by 1000. That is what is giving us 0.0002 meter. Now, substituting all these parameters into the equation of resistance, or the relationship of resistance with resistivity, length, and area. But before then, we quickly need to calculate our area. Since our area is cross-sectional area of the conductor, we use the formula for area of a circle to calculate our area, which is pi r squared. And so you can see the substitution there. Our r is 0.0002. So squaring that and multiply by 3.142, we have 1.26 multiplied by 10 raised to the minus 7 meter square. And substituting this into the equation of resistance, which is equal to rho L over A, we have the value of resistivity 3 multiplied by 10 raised to the minus 6 multiplied by our length 0.65 divided by the value of our area 1.26 times 10 raised to the minus 7, and this will give us 15.5 ohm. Let's consider one more example. Now in this example 2, we have the question says, what is the conductivity of a cylindrical material wire with a length of 1 meter having a resistance of 2 ohm, and the diameter of this cylindrical material wire is given as 0.5 millimeter. Writing now the given parameter, our length is 1 meter, our diameter is 0.5 meter. That can help us to get our radius. Remember, radius is diameter divided by 2. That's why we have our 0.5 divided by 2, and that will give us 0.25 millimeter. Converting that to meter by dividing it by 1000, we have 2.5 times 10 to the minus 4 meter. And the resistance of the wire is equal to 2 ohm. Similarly, we can as well find the value of our area using A equal to pi r squared, and substituting all this value into the formula of resistivity, which is equal to resistance multiplied by area divided by length. We have a value to be 2 multiplied by 3.142 multiplied by 2.5 times 10 to the minus 4 square. That is substituting the values of our area into the expression. Now remember, our length is 1, so it will have no effects on the calculation. That's why we are not dividing the equation by 1. So this one will give us a resistivity of 3.93 multiplied by 10 raised to the power minus 7 ohm meter. We are asked to find the conductivity, which is the inverse of resistivity. So we divide this value, we find the inverse of this resistivity, which is 1 divided by 3.93 times 10 to the minus 7, and this will give us 2.54 multiplied by 10 raised to the power 6 per meter. With this, we come to the end of this topic. In case you have any question, please feel free to drop your question in the comment section. We'll get back to you. And also, I think this time to remind us to please always click the like button if the video has added little knowledge to your knowledge. And also, you can as well please subscribe to our channel so that whenever a video is released, you will have access to the video. Thanks for watching.